Let's consider another alternating series. This one here. This is also an exam question, right? So let's take this alternating series, right? So the first quantity 1/2 and change the sign changes to negative, and second quantity also 1/2, and this sign changes to positive, and this quantity is positive. All are positive quantity. That is important. This alternative series: first term, second term, third term, fourth term, fifth term, and go on like this, right? But these are positive quantities, so these are positive quantities. An, all an is greater than or equal to 0 for all, and so then this is called an alternative series, right? Now if you want to check whether this alternative series is convergent or divergent, right? So if you want to check that alternative series is convergent, so you have to check two conditions. 1, 2, this sequence should be monotonically decreasing. This sequence should be monotonically decreasing, and the limit of this sequence should converge to 0 as n goes to infinity, right? Two conditions. All right. So these are subsequences of xn, right? X sub there. So if you look at this one here, if you look at these subsequences, so you can see that the limit of this subsequence does not converge to 0. That means you know that if any series, say this is a series, positive or negative, right? So I can define something like this: a sub 1 plus a sub 2. So general sequence, we don't know these quantities are positive or negative. We don't know general one, right? A sub 3. If you consider the nth partial sum of that series, which is say with this first sum of a sub n, summation up to a sub n, right? This is called nth partial sum of this sequence. This is an infinite series here. N goes from 1 to infinity, but this is a partial sum of the nth partial sum of this series, right? So if you look at, so we know that, so what is the difference between Sn and n-1. So the difference between nth partial sum and n-1th partial sum is same with a sub n, right? So if this series convergent, if this series is convergent, so that means this is a finite number, right? This is a finite number here. That means this partial sum, the partial sum is also a sequence, right? So this one also a sequence. S1 is this, S sub 2 is sum of first two numbers of that series. So this is a sequence. If this series is convergent to this number, this sequence partial sum goes to that limit, the same limit as n tends to infinity. This limit here, L is the value of this infinite series, right? So look at this. Let's take the limit of this expression. If you take the limit of this expression, this goes to L, this one also goes to L as n tends to infinity. The difference between L and L, then what happened? Xn, no, A sub n goes to 0 as n tends to infinity. What does it mean? If this series has a finite limit, if this series is finite, so if this series is convergent, that means if you sum all numbers of a sub n, you get a finite number. That we call it, this series is convergent, right? If this series is convergent, then we showed that the sequence a sub n all the time goes to 0 as n tends to infinity. This is true for all cases, alternative or anything, right? Now let's go to the question. So this is our question here. Now look at these two subsequences. These are subsequences of x sub n. Here they denote x sub n. I denoted a sub n here. Both are notation. It's a matter of using notations. Right? So look at this. If you look at this, so what is the limit of this? As n tends to infinity. N tends to infinity. So let's work out that. Here if you consider this subsequence x sub 2n-1, if you divide both denominator and numerator by n, so what is the denominator? 1, and this is 1 plus 1 over n. As n tends to infinity, what happened to this part? This part goes to 0, then all function goes to 1 as n tends to infinity. Therefore, this is a subsequence of this original xn. That means x sub n never goes to 0 as n tends to infinity, right? Because this is a subsequence of that original sequence x sub n. So that means this original sequence does not converge to 0 as n tends to infinity. Therefore, this series is divergent. It's divergent because of this. So, if it is convergent, actually, if x sub n is convergent, this implies the limit of xn's. This sequence goes to 0 as n tends to infinity. So if you consider the negation of the other way around, if xn does not go to 0 as n tends to infinity, so series is not convergent. Series is not convergent. Right? We showed that because of this here, this is a subsequence, this is a subsequence, this is a subsequence of this sequence xn. This subsequence converges to 1. That means the original sequence does not go to 0 as n tends to infinity. Therefore, this series is not convergent. Right? I hope you understood this problem here. Right? Alright. See you in another video.